The goal of this video is to help you understand the data structures, stacks and queues. Stacks and queues are both methods to linearly store, retrieve, and delete a list of data. They are specifically useful because they are flexible in size, which means you do not have to specify the size of the data structure in advance. To understand how stacks work, let's take the analogy of stacking up cardboard boxes. You can only add or push a new box onto a pile by putting it at the very top. You cannot put it in the middle or the bottom. And this same rule applies to stacks. The same applies for removing or popping from this pile, as you pop from the top of the stack. This is called LIFO, which is the last in, first out principle, as the last box you put on the pile is the first one you take out. The back button on a web browser is a good example of a stack implementation. Let's see how this works in real time. Let's say a user visits a web page, google.com, and searches for cats. Once the page leaves google.com to the search results page, google.com gets pushed onto the stack. Then let's say the user clicks the first result, which is this Wikipedia page for a movie called Cats. The results page URL is pushed onto the stack. Now when the user clicks the back button, the last page that was pushed onto the stack is popped off of the stack and loaded in the browser window, which is the search results page. Again, when the user clicks the back button, the stack is popped and loaded in the browser window, which is google.com. Let's talk about queues. Let's say you're in a store and you're waiting in line to pay for your stuff. You enter the line at the end and you get served after the people in front of you have been served. This is called FIFO, which is the first in, first out principle, as the first person to enter the line is the first one to be served. A good implementation example of queues is print spooling. Documents are loaded into a buffer, and then the printer pulls them off of the buffer at its own rate. Spooling also lets you place a number of print jobs on the queue instead of waiting for each one to finish before specifying the next one. So what about the performance of stacks and queues? The time complexity of adding and deleting an element for stacks and queues are both O of 1. The time complexity of searching for an element in stacks and queues is O of n, where n is the number of elements as you need to linearly go through the whole data structure to see if an element is found. The space complexity of both stacks and queues is O of n, where n is the number of elements in the stack or the queue. Thank you for watching this video, and I'll see you in the next one.